Hello and welcome to part 2 of my Super Pet restoration. In part 1 I took the pet apart and cleaned it and put it back together. And now in part 2 I want to do some basic electrical checks and visual inspection before I turn it on to see if it works. But before I do that, I thought I'd better explain what a Super Pet is and what makes it different from a regular pet. First, I should say I'm no expert on the Super Pet. I'm just starting to learn about them myself. I'll throw some links down below to more information written by people who know a lot more about it than I do. There are obviously some extra boards inside. This is a 3-board version of the Super Pet. There is a 2-board version which combines these 2 extra boards into one. The Super Pet is 2 computers in one. There's a normal 8032 Pet here, and the 6502 socket has a ribbon cable running up to this CPU board here. On the CPU board here, we have a regular MOS 6502, but we also have a Motorola 6809 processor. The Super Pet has a switch on the side to allow you to switch between the 6809 and the 6502. In 6502 mode, the computer starts up like a normal pet. When you start up in 6809 mode, that has its own set of ROMs and allows you to run different languages like Fortran and Pascal. It also has a real serial port for connecting to a mainframe. This other board is the RAM board. There are 4 rows of 16K here for a total of 64K dynamic RAM, and this RAM is accessible in 6809 or 6502 mode. With an old computer like this one, when you don't know the condition that it's in my opinion, it's really important to do a thorough visual inspection before you try to turn it on. So I get out my magnifying glasses and I get in really close and I look very closely at everything. I look at the capacitors for any signs of swelling or leakage. I look for any bits of wire or solder blobs on any of the traces that could cause a short circuit. I look for signs of cracks or damage to any of the chips, broken resistors, anything that looks wrong or unusual or out of place that might cause damage when you try to turn it on. This is a universal board, and you can tell a universal board at a glance by this row of jumpers here. These allow you to switch the board between 80 columns and 40 columns. So it's the same board in a 4032 or an 8032. I've noticed a problem right here. This chip wouldn't normally be socketed, and there's some flux or maybe some damage to the traces down here, so I'm going to take a closer look at this. There is some corrosion on some of the chip leads here, but I'm not seeing anything that makes me worried about turning it on. Nothing that would cause more damage. Just things to be aware of when troubleshooting later. On the back side of the board, I can see someone's obviously done some rework here on that one chip that I noted on the top side. They didn't clean up their flux here, so I'll probably clean this up a bit. And over here, there appears to be some heat damage to the board underneath one of these bridge rectifiers. This is actually pretty common and nothing to worry about, but sometimes these bridge rectifiers do smoke. One of the things you might want to do while you have the board out is to clean these contacts. They are really dirty in this case. One of the problems with the PET is that the power supply is integrated on the main board. You have your AC input here, your bridge rectifiers, and your voltage regulators. So there's no easy way to check the output of the regulators before you turn the computer on. If for some reason by chance one of these voltage regulators had failed in an overvoltage condition, when you turn it on you'll be applying an overvoltage to everything on the board. So if you wanted to be extra cautious, you could remove any socketed chips to protect them when you first turn it on. But on this board, virtually everything is soldered down. There's nothing socketed except the 6502 and a couple of ROM chips. So you pretty much have to turn it on and pray. In the last video, I took out the transformer, this whole assembly, and replaced the fuse holder. Well, one of the things I didn't talk about were the line filter capacitors here that are built into the IEC power connector. Inside this connector there are line filter capacitors, but as you can see, this is riveted in place, and I wasn't quite prepared to drill these rivets out and replace this connector at this time. That'll be for another video. This is an example of a replacement connector, and you can see it's got a whole metal can around it. And inside here there is an X-type capacitor which runs between line and neutral. And here there are two Y-type capacitors that run between line and ground and neutral and ground. These are often referred to as REFA capacitors, but they're there to prevent RF frequencies from feeding back into the power line. The trouble is when they get old, they start to fail, and when they do, they short circuit and put out a lot of nasty smelling smoke. You can also get this type, which don't have any filters on them if you're not concerned about radio frequency interference. It's up to you if you want to replace the connector before those capacitors fail. I'm choosing not to at this time. The capacitors in there are safety capacitors, so they shouldn't catch fire. And if they do fail, the computer should continue to work just fine once the smoke clears. I checked the voltages from the transformer in the last video, but after installing everything in the case, I'm going to go ahead and check it again. I have the voltmeter connected up to the blue pair, and we have 16.3 volts on the blue pair. On the brown pair, we have 17.5 volts. The red wires are DC, which we won't have until we connect it up to the rectifiers on the main board, and the black wires are ground. Back here on the transformer, these wires that run up to power the monitor are 21.8 volts AC. The 6502 is missing because it's up in the SuperPET processor board. I'm going to leave that out for now until after I've checked the voltages, and I've gone ahead and removed the other two socketed ROM chips. We're just testing for now, so I'm only going to screw the board down in one spot back here in the corner so it's grounded properly. I don't need the video connector or the keyboard connector right now. Just plug in the power connector. On this model PET, AC power comes in here on these two wires to the bridge rectifier. Bridge rectifier outputs about 9 volts DC unregulated on pin 4, which goes out to the big capacitor by the transformer. Then that 9 volts DC goes back in on pin 2 to feed the 5 volt regulator. On the other side of the bridge rectifier, we get a negative 9 volts DC, which goes down to this voltage regulator for the negative 5 volts. And the other two AC inputs here feed this bridge rectifier to provide the 12 volts for the 12 volt regulator. The first thing I want to look at, of course, is the regulated 5 volts output, and according to the schematic here for the universal board, we should be able to see the output of the 5 volt regulator on the positive side of C11. So I have my multimeter connected here to the positive side of C11, and the other lead is on ground. So I guess we can turn it on now and see if we get 5 volts. 4.8. The tolerance is plus or minus 5%, which gives us a 1/4 volt in either direction. So 4.8 is within tolerance. Pin 1 of J11 should show us the unregulated 9 volts. 10.2, close enough. On the positive side of C7, we should see plus 12 regulated. And there it is, 12.08. The negative 5 volt regulator is over here, VR1, and we should see negative 5 volts on the negative side of C1. And there we go, negative 5.16. I just want to see if the PET side of this works first, so I'm going to go ahead and lift the 6502 out of this socket and move it down onto the PET. Pins look okay. Better connect up the video connector and the keyboard. Here goes nothing. No startup chirp, no picture. Well, the PET's not showing any signs of life when I turn it on, so I've got the Romulator here. This is a known good 6502, and I have the switches configured for basic 480 columns. And this will replace the RAM and the ROM, and if it works, that'll tell us that there's a problem with the RAM, probably, or with the kernel or edit ROM. Here we go again. And there's the startup chime. See if I can turn the brightness up anymore. And it looks like we clearly have some problem with the video RAM. There's definitely some bad video RAM in here. Alternating columns are showing incorrect. The video RAM are these 4 2114 static RAM chips right here. 2 for even column and 2 for the odd column. I went ahead and swapped the original 6502 back into the Romulator because I want to check that to see if it's okay. And these are the basic switch positions for the different ROMs available in the Romulator, but there are also a few extra ones here. We have no-op and PET test, test ROM, and RAM test here. So I'm going to try PET test QK at switch position 13. So this is the PET test ROM, and it's doing what it should be. It writes this pattern to video RAM and then reads it back to verify that video RAM is good. But we know the video RAM is bad. So if the test fails, it continues looping so that you can see it, and it won't get past this until video RAM passes. I also have this timeout board, and it can be configured to selectively replace either bank of RAM or individual ROM chips. So right now I have it configured for 8032, 60 Hertz with these switches on, and it's configured to replace all the ROM and all the RAM, just like the Romulator does. Startup chime. Standard startup picture with the bad video RAM. The switches are configured now to use the onboard RAM. And we get a startup. So I guess the onboard RAM is okay. Now I switched off 3 and 4 so that all the ROMs have been replaced except the kernel ROM. So we should be starting up off the onboard kernel. And we don't get a startup. And now all the ROMs are replaced except the editor ROM. So it looks like the edit ROM is okay. So at a minimum, it looks like we have 1 or 2 bad static RAM chips for video RAM, and we have a bad kernel ROM. So I'll have to get those replaced before proceeding, and then we'll see if we have good system RAM. First things first, I guess, I need to desolder these 4 video RAM chips and socket them so I can replace them one at a time and figure out which one's bad. I've got the 4 chips marked on the bottom of the board here so I don't get confused as to where I'm at. I've got my desoldering iron warmed up. Give it plenty of time for the heat to soak in. Make sure I got the notch facing in the right direction on all these. So I got 4 sockets installed and the flux is all cleaned up. I have a stash of 2114s, so I just decided to replace them all, and then maybe I'll swap out the old ones one at a time to see which one's bad. But these are 300 nanosecond chips, which match the original. And it looks like we've gotten past the video test. I'm going to try adjusting the vertical height. The DRAM test is looking promising so far. And it seems we passed the DRAM test at least one time. The DRAM test has now gone through 3 full passes with no failures, so I guess the RAM is good. All the other tests passed very quickly. So the only problem left now is the ROM. I assume one of these ROM checksums is wrong. Some of the keys appear to be working. See a number changing there, there. Shift lock is changing right here. Probably need to clean the contacts because some of them aren't working. Space bar showing a intermittent response. I've also used a time mouth board to go through all the different combinations here, and the only onboard ROM that it won't start with is the kernel. Now I need to remove the bad kernel ROM, which is here at UD5. Give the tip plenty of time to heat up the pad and the leg. Melt the solder thoroughly. I like to tilt the board up sideways or vertical like this just to so the solder sucker doesn't have to fight against gravity. So I've got the kernel ROM socketed, and I went ahead and burned an EEPROM to replace it with, but I need to use a socket adapter to get the EEPROM to work in there. The Romulator and the Tynemouth board are set aside. I have the 6502 directly in the socket here, and I have the EEPROM replacing the kernel ROM. There's a startup chime. And there it is, Commodore Basic 32K. I think the keyboard's going to need some work. Now that the PET's working on its own, I want to put the Super PET boards in and see if they work. But first, I need to clean the keyboard. And that part's kind of boring, so I'm going to try to zip through that as fast as possible. First, I need to desolder the shift lock key. When you desolder the shift lock wires, and more importantly when you resolder them on there, it's important to not get it too hot. Use minimal heat and for a minimal amount of time. Too much heat will melt the locking mechanism in the shift lock key. This board is really dirty, so I'm going to wipe it down, clean it up. The other thing that can go wrong with these is these traces right here. These are very, very thin and brittle, and sometimes they crack and cause the keyboard to stop working. So I'm going to do a very close visual inspection on all of these traces. Also, while you're cleaning these gold contacts, be careful not to touch them with your fingers afterwards. 1500 grit sandpaper. All the keys seem to be working fine now, so I'm going to go ahead and just put all the screws back in, put the keyboard back together. Now I'm going to put it all back together and see if it works. First thing I need to do is take the 6502 out of here and put it back in the Super PET processor board. I'll get these cables out of the way. The keyboard cable needs to go underneath, and the video cable needs to go over. And the power cable is going to go into the processor board first. And I'll install this processor ribbon cable. That one goes there. Four standoffs. Forgot to install the switches first. This one goes on the processor board right here. The other switch, or rather the other switches, one of which is missing, are here to switch on and off the option ROM sockets. But as you can see, they're pretty messed up. This one, the EEPROM that was in there, was rusted so bad that several of the legs pulled off when I tried to remove it from the socket. So this socket's no good anymore in any case. So I'm going to need to get parts to replace these. In the meantime, I'm hoping the 6809 side works without these. I have the switches here set for read-write and 6502 mode. Well, here goes the smoke test. No sign of life. Well, since it's not working, and I really don't know if it will work at all without these switches installed, I went ahead and tried to bend these pins back, but most of them broke off, of course. But at least I have the 2 pins that these wires connect to, and I'll connect this up and see if that gets it started. So now that I have these 2 sockets installed, I'll go ahead and put it all back together, see if it works this time. And that's a no-go. Problem is, this tower is now too tall and is interfering with the bottom of the board, so it has to come out. And we'll just see if just having the switch connected does anything. Alright, so now I have everything put back together just the way it was, with the only difference is this other switch is connected, although it's not connected to the socket. The switch is in 6502 mode, and there's the startup chime. So PET side works. Switch to 6809. Here we go. No sign of life. Switch on the side seems a little flaky. Switch it back to 6502 mode, it boots up in PET mode. Switching to 6809 though, I think the switch might be broken. And of course those ROM towers aren't there in the first place. So of course the Super PET side is not working. But there's still a lot of work left to do on that side. I have to rebuild those ROM towers and I'll probably end up replacing those switches. But this video has gone on long enough, so I'll save that for part 3. Thanks for watching.